Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our grade 11 math content. What we're going to cover today is going to be somewhat of a review here in terms of completing the square, but we're also going to go through the method of partial factoring. So with that, let's get started. Alright, so here we are. I put completing the square and partial factoring. Okay, so first off, let's try an example here. And we're going to start with completing the square. Okay, so say I have this question, y equals x squared plus 4x. Okay, and again, I don't need to have a third term here. Okay, what you're going to do is I'm going to find the perfect square. Okay, I'm going to take the middle term, which is 4, in front of the x. You're going to divide it by 2. So I see that my perfect square is equal to 2. Okay. And what you're going to do is inside the brackets, x squared plus 4x. And I'm going to add and subtract my perfect square. So I'm going to do plus 2 squared minus 2 squared. And then close the bracket. Does everyone see that? So I'm going to show some extra steps here, okay? So x squared plus 4x. And 2 squared is 2 times 2. So we're going to do plus 4 minus 4 and close the bracket. Okay, within the next step here, you're going to take this negative 4 outside. Okay, so it becomes x squared plus 4x plus 4. And I'm taking the minus 4 outside. So again, remember that it's still going to be negative here. So even when I did 2 squared here, do you notice that it's negative 4? Okay, and that's because the negative sign is on the outside. Okay. And in this last step, I'm going to, what we're actually doing is factoring what's on the inside. Because I know this is a perfect square, I don't need to do the sum and products, okay? X is going to be x plus, because the second sign is positive, x plus my perfect square, which is 2. So you can do x plus 2, and I'm going to write it here so you can see, and x plus 2 minus 4. Okay, because I have x plus 2 two times here, I'm going to put x plus 2 whole squared minus 4. Okay, and make sure you plug back the y. Okay, so that's going to be your final answer. Okay, and you're not just completing the square. You're going to actually state what the vertex is. Okay, so let's write it here. The vertex should be as a coordinate. Okay, so if I look at this equation here, you see how it's x plus 2? I'm going to put x as minus 2. Okay. And this minus 4 here is actually the y-coordinate of the vertex. I'm not going to change the sign. So my vertex is negative 2 and negative 4. Okay? And it's as simple as that. Okay, you start off with the standard form of the quadratic equation. I'm converting it to the vertex form so I can find the vertex at the very end. Okay, are there any questions here? All right. So with that, let's try one more example. Okay, let's try this one. So I have f of x. So when you see f of x like this, okay, that just means that the equation is a function. And we're going to try an example where there's a number in front. So negative 3x squared plus 6x plus 1. Okay. So what you're going to do in this first step is whatever is in front of the x squared, I'm going to take that out, okay, or outside the bracket. So x squared. And I'm going to do 6 divided by negative 3. So negative 2x plus 1. Okay. So a mistake that some students make is they'll start taking the perfect square of the 6. Okay. And that's not what we're doing here. Okay. I have to make sure the coefficient in front of the x squared has to be 1. Okay. So when you take your perfect square now, I'm going to take the 2 divided by 2, which is equal to 1. Okay. And let's circle it. So that's my perfect square. Again, I don't need to really use that negative sign because I'm going to just add and subtract my perfect square. So x squared minus 2x, okay? Then plus 1 squared minus 1 squared, close the bracket, plus 1. Does everyone see that? Okay? And what you're going to do in the next step is take this negative 1 outside. So let's write it out. Negative 3x squared minus 2x. 1 squared is just equal to 1 because it's 1 times 1. okay? Before you take this -1 outside, make sure you are multiplying it by -3. -1 times -3, so +3 plus 1, okay? And now again, I'm just factoring what's on the inside here. But again, I don't need to factor it. It's going to be x minus, because that first sign is minus, 1 whole squared. That's my perfect square there. And that's the number that I'm using here. Okay, and add these numbers on the outside, which is equal to 4. So this is my function now. It's f of x equals -3, x plus 1 squared, or whole squared, plus 4. Okay, what I want to do here is just state what the vertex is. So one more time, whatever's on the inside here, x minus 1, I'm going to change the sign. So it's going to be +1 and +4. And don't change the sign for the y-coordinate of the vertex. Okay? All right, and that's basically all you're doing here. I'm completing the square, I'm finding the vertex. And again, the reason we are changing it into the vertex form is so that we can actually graph out the quadratic very easily. Okay, does anyone have any questions? All right, so that looks good. Okay, so let's move on, okay, to our next method here. And our next method is going to be on partial factoring. Okay, so let's try an example here. Okay, so we're going to try, let's do f of x equals -2x squared plus 8x minus 3. Okay, so this is what the equation looks like here. Okay, and what we're going to do is partially factor, okay, these two terms at the beginning. So I'm going to take out a common factor, so -2x, and in brackets, what's left over is x. 8 divided by -2 is -4, and then minus 3, okay? And this time when you do the partial factoring method, I have to take out the GCF here, okay? So I'm taking out the x, okay? I'm going to make both of them equal to 0, so -2x equals 0, and then divided by -2 on both sides. So it cancels out, okay? 0 divided by -2 is still equal to 0. So this is my x-intercept. And on the other side, we're going to do x minus 4 equals 0. And then take the -4 to the other side, so it becomes positive. So +4, okay? So a question says, use partial factoring to determine the vertex of each function and state if the vertex is a minimum or a maximum, okay? Now say I'm solving for the vertex here. Okay, I always write Vx. This is the x point of the vertex. I'm going to add my two intercepts together, so 0 plus 4, and divided by 2. So 4 divided by 2 is equal to 2. Okay? When you're looking for the y point of the vertex, you take this x value, plug it back into your original equation. So I'm going to write out the equation here. Minus 3. So -2, and you're going to times it by 2, so 2 squared, plus 8 times 2 minus 3, okay? So again, make sure you are showing, okay, all of your work as you do it, okay? Make sure you're doing the exponent first here. So 2 squared is 4, and this is going to be already here. 4 times -2, so -8. 8 times 2, so 16. Okay, and then minus 3. Does everyone see how to do that? So basically, we are just evaluating, okay, our answer here. Okay, and you should be getting +5, okay? And that's basically my vertex here, okay? So the vertex is equal to, I'll just put a V. My x-coordinate is 2 here. Okay, my y-coordinate is 5. And that's what I'm getting for my vertex, okay? Now say I did want to just draw a quick sketch of my graph for my quadratic. Okay, so we're gonna do 2. Okay, can everyone see that? And 5. So remember again, I'm doing my x and y values here, okay, for my vertex. Okay, so it's going to be 2 and 5. So the vertex is right here, okay? If you look at the original equation here, you notice how there's a negative sign in front of the x squared, okay? Which indicates, okay, that my parabola is actually opening down. It's going this way, okay? And again, I just made it like a sketch over here, just so we can see which way the parabola is opening. Okay, because I do have to determine, okay, whether or not this equation is or the vertex is actually creating a maximum or a minimum. Okay, so anytime you do have the parabola opening downwards like this, okay, this is going to be a maximum. Okay, and in contrast, okay, if you have a parabola that opens like upwards like this, okay, and you can see the vertex is on the bottom, okay, in this case, this would be a minimum. Okay, so I can see the definition for the maximum and minimum is coming from whether or not the parabola is opening upwards or downwards. All right, and that's all you're doing over here, okay? So what we are producing here is a maximum with our vertex of 2 and 5. All right? All right, so that looks good. And that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks. Bye.